Assalamualaikum and good afternoon to all the panels and my fellow friends. My name is Fachrunnisa Izzat and I will be presenting my final year project entitled Biofouling Growth-Resistant Assessment of Different Materials Using Field Test Method in Pulau, Tuba, Langkawi, supervised by Dr. Muhammad Akmal Hashim. So biofouling in definition is the undesired accumulation of organisms onto a surface of a submerged structure in an oceanic environment. Biofouling is one of the main problems faced by the marine industry due to it being cost ineffective and can lead to structural damage and corrosion. Biofouling can be prevented through anti-fouling coatings and materials. However, a universal anti-fouling solution is still difficult to produce due to the intricate relationship between the fouling agent and the media. So the problem statement for this study is to evaluate the potential materials that can postpone biofouling in a long duration of time. The significance of the study is that the project will be beneficial in furthering the research on materials with anti-fouling properties and the development of anti-biofouling surfaces. The aim of the study, the general aim of the study is to determine and compare the different materials that may be suitable for biofouling and discussing how the materials are able to inhibit the biofouling process. The research questions comprise of what are the composites of the best materials and how they delay the biofouling occurrence. So from the literature review, it is revealed that biofouling is the Achilles heel or the weakness of the marine industry. The process of biofouling starts within the seconds of submersion and progresses through the stages of conditioning film, adhesion of pioneer bacteria, soft macrofouling, which is temporary attachment, and hard macrofouling, which is permanent attachment. Note that soft and hard macrofouling may occur simultaneously. There are three types of fouling coating methods, which are fouling resistance, which prevents adhesion of algae and bacteria through strong hydrated surfaces, fouling release, which can be easily removed by limited shear force, like a water jet, and fouling degrading coatings, which degrades the adsorbed organic material through oxidizing agents. The examples of anti-fouling coatings that are popular now are polymer brushes, monolayers, and slips. So the effects of biofouling, these are one of the few effects, which is biocorrosion, increase in fuel consumption. The point here is that due to the increase of the weight of, for example, a ship, is due to the volume added by biofouling, causing a ship to increase their power and ultimately fuel to move. That also includes emission of gases and invasion of non-species into the marine environment. Next is methodology. These are the plate samples before the experiment was conducted. This is twill weave basalt fiber chopped strand matte glass TWP CSMG, twill weave glass fiber CSMG, Wilcat flexural, and Wilcat tensile. So these are the fiber samples: the unidirectional basalt fiber, the woven glass fiber, the twill weave basalt fiber, and the CSM chopped matte glass fiber. The location of the marine field test was at Chalet Terapung, Tuba. The plates were secured onto the side of the experimental raft, while the fiber samples were placed in makeshift jars that had punctured holes, so there was free flow of seawater. The time of observation was on day 0, day 3, day 14, day 28, and day 49. Next is the observation and the statistical analysis. The results were evaluated by the percentage of biofouling attachment, the rank of biofouling, which was based on the mean percentage of biofouling attachment, the two-way ANOVA analysis, and the general classification of fouling organisms based on the articles published by Ratani in 2018 and Lindholt in 2015. Here are the observational results of the plate samples. As you can see, biofouling starts on day 14 until day 28. For TWG CSMG, TWB CSMG, Wilcat flexural, and Wilcat tensile. So as you can see from the observational and the percentage plate results, they all have very similar results. All 4 plates exhibit no biofouling on its surface until day 14, where there are slag formation and bryozoan incrustation on its surface. The mean percentage from day 14 to day 28 is 100 due to the full coverage of fouling organisms. The rank of fouling form from day 14 until day 28 is 5 due to more of the 10% of the surface had the presence of biofouling. As there is no variation between the plate samples, the ANOVA results was unable to produce accurate results. As you can see from the array there, the p-value cannot be determined since there is no difference of biofouling attachment between the plates tested. One of the reasons of the plate samples having been affected by the biofouling is because of the surface roughness of the plates. That had a role in the attachment of biofouling, as Lindholt in 2015 had stated that surface roughness may encourage organism settling. So here are the fiber samples. The yellow circles circle the visible biofouling that can be seen on the fibers. So as you can see from day 14, there is a lot of biofouling, but it decreases by day 28 and day 49 for UBF. And WGF, there is biofouling on day 49. For TWBF, as you can see from the condition, I will explain. And CSM, there was only biofouling on day 28. So from the percentage, you can see that UBF exhibits biofouling from day 14, but it decreases progressively in day 28 and day 49. According to Mothukrishnan in 2022 and Patel in 2021, UBF may have gone through stages of biofouling since there was both soft and hard macrofoulers observed on the fiber. The decrease of biofouling may also have been because it is a fouling release material, which can be cleaned by applying shear flow like a water stream, as Mann in 2020 had stated in his article. Next is WGF. WGF shows no biofouling until day 49 when a hard shell organism was observed on its surface. So the glass fibers are known to be one of the most important reinforcing materials for the marine structures, with their cost and strength, as Sapwan in 2020 had stated. So this holds with the result, as WGF shows that it has a greater capacity to prevent biofouling than other samples. Next is TWBF, which shows no biofouling throughout the 49-day observation. However, this finding could not be acceptable due to the detangling of the woven fiber, which affected the observed surface and ultimately affects its results. Lastly is CSM, which exhibited biofouling on day 28, but it is found to be clean on day 49's inspection. This is due to the soft macrofouler on the surface that are simple to detach and can be easily removed, as noted by Mann in 2020. On day 40, we can see that UBF has the highest rank of biofouling with 5, but it decreases on day 28 with 4 and day 49 with 4. And WGA displays the lowest rank with 3 on day 49. And for CSM, there was only the rank of 4 in day 28. So from the ANOVA results, we can see that the fiber samples are considered extremely significant to affecting the results with a p-value of 0.0004. With the material accounting for 25.91% of the total variance. So in conclusion, the findings of the test indicates that woven glass fiber is the most effective material to combat biofouling compared to all of the samples. The second best is CSM, which is also quite effective in mitigating the biofouling. The recommendations that can be given is the additional testing such as durability test, which can investigate on the mechanical properties of the materials, and the microbial assay, which is, for example, a bacterial assay, which can investigate the inhibition of bacterial growth to further the study on the materials, and also use a larger sample size and longer exposure of the materials to the seawater and to have an adequate assessment. Thank you for listening. So the materials, as you can see, there was the fiber samples and the plate samples. So the composites of the materials are mostly based on basalt fibers and glass fibers. So how do we classify? Sorry?
What are your test subjects and what are the controls? Do you have controls?
The control is the day 0. Oh. Oh, okay. That would be. We do not have control for this experiment because we do just want to see the biofouling assessment, whether there is a biofouling on the materials or and how long for the materials to have biofouling.
Different material use.
Which one? Yes.
Okay, basically you compare by day.
By day, yes.
I think it's not clear. Your by day,
Oh.
measure.
We have 3 variables that we observe, which is the time of observation, the materials, and the percentage of biofouling attachment.
Because when we try to do the time, insert into the statistic, there must be a repeated measure. You need to consider that. Kemudian, saya tidak pasti why using the ANOVA sebab your data set tu very small. They supposedly they need to have more data so that they can fulfill the assumptions of ANOVA for normal distribution. The ANOVA is quite complicated. They need to have normal distribution in the data set. Kalau tak boleh guna ANOVA, we need to use a non-parametric test. Non-parametric, for example, we have the fragment test from Pulau. Go to the next, your data set. Okay. For example, that one 14 and 28. Jadi 14 and 28, they show no difference. Basically, it's the same. Kemudian 3 and 0 is similar also. Dia sebab tu dia tak dapat. It's very good. Jadi the test itself is a wrong test lah. I believe it's a wrong test. Jadi we need to consider other part. Sebab kalau kita tengok kat situ 555,000, dia data tu dia not normally distributed. Jadi kita guna ANOVA. Jadi kita kena do something yang mana dia tak guna mean extended derivation, dia akan rank dalam data set supaya dia ada difference letak between the base tu. The best one is
WGF.
On your objective, they have a relationship, right? Jadi how do you determine the relationship in your result?
So the type of materials. goes by, the materials will be affected by biofouling, or we are trying to find the one that can delay biofouling. So WGF is the best to postpone the biofouling.
So how do you differentiate the WTF using the ANOVA, right?
The ANOVA was on all the fiber samples.
Jadi yang Thesis tu, Thesis yang Thesis. This one is Thesis.
Yes.
This means WTF is the best.
Yes. Because the TWBF was affected by the detangling.
Tapi yang WTF tu boleh kosong.
Because let me show you. Yes, there it is. So cannot be observed.
So I assume the same Greek method. So this WGN, right? It has been used, right? So what does this project have to do with the current knowledge?
This project is able to so the WGF is in fiber. So what I understand from this study is that it will be used as a coating material.
Is it not being used right now?
It's been used as a I cannot put this in the article, I'm sorry.
Tapi yang CSM D49 itu bila hilang, bila zero.
Because of the soft fouling species on day 48 was easily removed. So during day 49, it was probably gone.
Jadi CSM maybe can be better than WTF. Because all the biofouling is zero. Then we can rank CSM as the best.
I had put that CSM is also one of the best of the materials, yes.
Taking two 3.2 and 4.82 is the two different samples.
Yes, because fiber samples, there are 2 samples, and for plate sample is 4. Yes, one sample, for example, TWBC SMG, there's 4 plates.
4.
Yes. Like, for example, here, there's 2 of each of sample, yeah.
Because CSM tadi, you identify the types of the falling. Jadi sampai you buat satu conclusion, might be due to soft falling species can be easily removed. Day 28. Day 28 kan dia cakap, okay, you can see ada falling species, right? We identify the types of them.
I identified through the pictures of the reference from the articles that I have put in methodology. For example, here, let me show you. Okay, from the general classification of fouling organisms. I do not specifically say what type of, what species it is, but I do say if it's a soft fouling mechanism or a soft fouling organism or a hard microfouling from these pictures. as my references.
Anggaran saja, not the exact data, exact findings to say that is the soft audit. Maksudnya tak ada spesifik. Dan statement yang dibuat lah kan.
Yes. Nama kita.
Yang dekat CSM kita ada malu.
Okay.
So this one you tengok dekat calling sama tak dengan calling yang ada dekat Thesis? Types of calling CSM dengan Thesis organism.
I would say no. Thank you.